All right, today we're going to start talking about inverses. And to do that, we're going to talk about them graphically first, and then we'll do a little bit of the definitions and then move on to equations. So we start here, and it tells us NASA intends to introduce the next generation space shuttle in 2030. And so we got an elementary schematic right here of this rocket. So we want to start for table one, getting the points of this rocket from the top here to the bottom. So my first one here is at 4, 4. So I'm going to fill out table one with these points. Our next one here is at -2, 1, and then -6, 1, -3, -1, -4, -2, and our last one's there at -3, -3. Now we're going to want to reflect this rocket across the y equals x so we can get the other side of the rocket. So go ahead and sketch your other side by reflecting over this y equals x so they could be both the same on both sides. All right, so I have gone ahead and drawn the rest of the rocket, and this is what we're going to put in table two, the points for that second side there. And so I've got a point at 4, 4 again. And then our next one's at 1, -2. Our next one's at 1, -6. And then we've got -1, -3. And then -2, -4. And then -3, -3. All right, if we look at our two tables now, you should recognize something. So the 4, 4 is hard to see because that's the same. But on our next one here, went from -2, 1 to 1, -2. And -6, 1 to 1, -6. So my x values and my y values have switched. That's what an inverse is, when we're switching the input and output values of a function. So right here, x is our input, y is our output, and we have switched them. You can also know an inverse because it is the reflection across this y equals x line. So that's our relationship. It is an inverse. The input and output values have switched. All right, to help us some more of this vocab, the next part there says to find the inverse. Oh, it's worse. To find the inverse, we simply switch the x and y values. There we go. The inverse is a reflection of a graph over the line y equals x. So that's part of the definitions there you want to hang on to. You want to know that the inverse is when we're switching those x and y values or the input-output values. And they are a reflection over that y equals x line. So let's look at another graph right here. And so it asks for the domain and the range of this graph. For our domain, the first value here is -9, and my last one is +8. There is a point at -9 and at 8, so we're going to do brackets there for our interval notation. And then we're going to look at our range. And so that starts at -2, and then it goes up to 9 there. Those are my y values, and there is a point at both of those. So again, we're going to have brackets. Now it tells us to draw the inverse. And so you can do that by drawing the y equals x line and reflecting it, or we said that's when you switch the x and y values. So this first point here that was at -9 and +5, I would go to +5 and then -9, and that would be my first point. Then I do the same thing for the next one, -6, -2. So -2, -6 is my second one. And so we've got that line there. Then our next point is 0, 0. If I switch 0, 0, it's still 0, 0. So we've got that one. Our next one here is 2, 4. So I can go to 4, 2. And then we've got one at 5, 9. And so I'm going to go to 9 and then 5. And then my last one is at 8, 8. So it's actually that same point. So we can see the reflection right there of y equals x, but that's my inverse one, is that pink one. And so if we look at the domain of that graph, the domain starts at -2 and goes to 9. That's my biggest x value. And the range of my pink one, it starts way down here at -9, and its top point is at 8. Well, look at that. Now, if we compare the two, we see that the domain switched to be the range here, and the range switched to be the domain. Since we switched our input and output values, and domain is our x's and range is our y's, then when we've switched it, we've also switched the domain and range. All right. On the back side here, we're going to go ahead and review some of the stuff from the unit we just got out of. So we just got out of quadratics, so we should be really familiar with this. Looking at this equation right here, some of the key characteristics, the vertex we know is these 2 points right here. So our vertex is at 2, 4. So I'm going to start by graphing that point right here. And then the direction that it opens. Well, the A value here is positive. There's nothing written there, so it's 1. And so this is going to open upward. We know the domain of quadratics are all real numbers. And then the range would be from that vertex value up. And so that's 4 to infinity. Now we just said the vertex, so we know that point is included. And so I'm going to start in the middle here with that 2, 4, my vertex point. And we know that the quadratic goes up 1 and over 1 on both sides. So that's going to be the 2 points there. And then it goes over 2, up 1, 2, 3, 4, because it's x squared. And so 2 squared is 4. And so there is our parabola. And so if I filled out my points here, this would be at 5. And then this one we said is at 8. And so there is our points. Now, if we talk about the inverse of a quadratic, again, we would flip these points because that's what an inverse is. You're switching that input and output value. And so now we can graph these. And so our new vertex is at 4, 2. So it was at 2, 4, now it's at 4, 2. And then we've got the point 5, 1 and 5, 3. And then we've got the point at 8, 0 and 8, 4. And so there is our inverse. You can clearly see it's a reflection across that y equals x line. You can also see that the points have switched from the input to output. And so our new one, the vertex is at 4, 2. It is opening to the right. And our domain and range has switched. My domain, it starts right here at 4 and goes to infinity. And for our range, this goes all the way down and this goes all the way up. So we're talking about -infinity to infinity. All right. The hardest part of inverses is really writing the equation and really thinking through that. So we're going to start with writing the equation here for our inverse to this quadratic. And so we said for an inverse, you switch that input output. So you're switching the x and y. So that should always be your first step. Switch that x and y. So x is equal to y minus 2 squared plus 4. I have switched my x and my y values in this equation. Now in math, y is our dependent function, our dependent variable. So we don't want to leave it inside of the equation. So we want to solve for y here so that it is on its own. So I start by subtracting this 4 to get it to the other side. So I get x minus 4 equals y minus 2 squared. And then we need to get rid of this square. To get rid of a square, we take the square root. Now, anytime you take a square root of a square, you need a plus or minus on this. So we have released the y minus 2, and then I've got a plus or minus x minus 4. My last step is to get this over here. And so we get y is equal to plus or minus x minus 4, and then I've added the 2 to get it to the other side. So this was minus 2. I'm going to add 2 to get it to the other side. The reason why this plus or minus here, if you think about that, when we talked about the square root function at the beginning of the year and we introduced you to all those parent functions, if you remember, that's what the square root function looks like. So that's this top part. We need this bottom part too. That's where this negative comes from. It's a reflection, and so it gives me the second part here to give me this true reflection of our quadratic. Now, this is not a function. It fails the vertical line test. We've got two output values for one input, so it is not a function. So most of the time, we will restrict the domain to make sure that is a function. But since this one was a full quadratic and we wanted its full inverse, then we've got it there. The last step after you do this is to put the proper notation. This is the notation for inverses. That's what that means right here. So this was f of x. This is the inverse of f of x. And so we list it as plus or minus the square root of x minus 4 plus 2. So here is my function. Here is my inverse. All right, let's do it the other way now. So now we know that a quadratic and a square root are inverses of each other. So this time we're going to start up with the square root, and then we're going to move it over to, we're going to get its inverse, which is a quadratic. All right, we know enough about transformations now to know this is the vertex. Our C and D are going to be that vertex value. And so this went to the left 3 and down 2. So this is going to be at -3, -2. We also know this is going to open to the right because it is positive in both of those. There's no reflection. And so for my quadratic that we were just talking about here, it starts at the vertex and moves to the right. And so if this is my vertex, then I'm starting at -3 and moving to the right. So infinity. And then my range would start at that -2 from my vertex and going up forever. All right, so let's talk about a couple points. We just said -3, -2 is found on this graph. I do want to talk one to the left, -4. If I put a -4 right here, -4 plus 3 is a negative under the square root. We've talked about that's not a real number. So it is undefined there. There's going to be no point on the graph where that happens. And that's going to happen for any point to the left of that. So my next value would be -2. So -3, -2 is right here. And we know the parent function goes over 1, up 1. So we've got a point there. I missed a point there. Sorry about that. -3, -2 is right here. And then -2, -1. Now, the next important point for a square root, since it's a square root, it's the perfect squares. So this would be the 0, 0. This would be the 1, 1. The next perfect square is 4. So 1, 2, 3, 4. And the square root of 4 is 2. So that gives me that point at 1, 0. And then the next one would be 9. And so right here at 6, 1, 2, 3, because the square root of 9 is 3. With the square root, you're always going to want to look at those perfect square values. So there is our radical. Now, to find its inverse, we want to go ahead and flip those values. So this would become -2, -3. We've switched our input and output. -1, -2, 0, 1, and 1, 6. So I'm going to go ahead and put those on the graph so that you can see those next. So -2, -3. And so our graph looks like that. As you can see, it is a reflection across that y equals x line. Our vertex is over here at -2, -3. For the direction, this is going up. For my domain, it is going from -2 to infinity. We'll go back to that. And then our range is going from -3 to infinity. And again, we'll go back to that. So for our equation here, remember, our first step is to switch that x and y. So I get x equals the square root of y plus 3 minus 2. I'm going to add the 2 to get it to the other side. Our goal is to get the y by itself. So you always take care of everything away from it first. So I'm going to add that 2 to get it to the other side. Now, to get rid of a square root, we square. So I'm going to square both sides. That square root and that square cancel out. So I freed the y plus 3. That's our goal, is to get that y by itself. So I need to free it so that I can then get it by itself. My next step is to subtract that 3. So I get y equals x plus 2 squared minus 3. So this is where we have to stop and really think through this. We just got out of the quadratic unit. So we know that a quadratic that moved to the left 2 and down 3, left 2, down 3, looks like this. Well, that's not what this looks like. This is only one side of that. So we need to restrict that domain to everything to the right of that vertex. So when you write this inverse function, you will have to restrict the domain. We want every point to the right of it because that's what this is right here, the right. We do not have the left-hand side of this quadratic. So when I write this, I have to say x has to be greater than or equal to -2. That is called a restricted domain, and you must include that because if not, then you've got that other side, which is not a true reflection because this one does not have a side, another side here. So keep that in mind when you are writing those inverse functions. We'll try another one. And then I'll give you a shot at trying some. So right here, we've got f of x equals 2x squared plus 4. And we want to focus on writing this equation. So to find the inverse of a function algebraically, we switch x and y, and we solve for y. So remember, inverse, switch that x and y. Now, in this one here, students see this and they want to plug points in and do all kinds of weird stuff. The reason why that's there is because that is that domain restriction to keep only one side of the quadratic, which is the inverse of a square root function. So you do not have to do anything with this. They are giving you the restriction so that you know it is the square root. And we'll talk about that a little bit further in a second. So I'm going to start by switching my x and my y. Then I'm going to solve for y. So I subtract the 4, divide by 2. And so I've got y squared is equal to x minus 4 over 2. Now I'm going to take the square root because I need to get rid of the square. So I take the square root of both sides. And so this is where we talked about if we take the square root of a square, you need a plus or minus. Well, we don't because we have this domain restriction. That's where this comes into play. Because I have this domain restriction, I don't need the plus or minus. And so I've got y is equal to the square root of x minus 4 over 2. And of course, we write it in proper inverse notation. That's with this -1 right here, x minus 4 over 2. I think it's time you try some, so go ahead and try 13 and 14. Pause the video, give them a shot, and come back and check them to see how you're doing. All right, so I've tried those. Check your work. Make sure that you got the domain restriction, which is right here. This one needed a domain restriction to make sure you only had one side of that parabola. Again, square roots and quadratics are inverses of each other. So if I start with a square root, I'm going to end with a quadratic. If I start with a quadratic, I'm going to end with a square root because they are inverses of each other. All right, I want to try a couple more with you just in case you're still struggling. These two are similar to the ones we've just tried, but they do look like the test questions will look. So I want to make sure that I show that to you. It says find the inverse of this function given that x is greater than or equal to 2. So again, if you've got that domain restriction, then you know that you only need one side of that square root. So I switch my x and my y. I said it and then I didn't do it. Right there. Now I start solving for that y. I need to get this by itself, so I'm going to bring this over. So I get x minus 4 is equal to y minus 2 squared, negative that is. Now I need to get rid of the negative. So I'm going to change the signs on both sides or divide by a -1 or multiply by a -1, however you think of that. But we need to get rid of the negative first. And so that becomes -x plus 4 is equal to y minus 2 squared. Now it's time to take the square root. So we take that square root. Remember, I do not need the plus or minus because I'm only going to use the one side of the parabola. And so now I've freed my y minus 2. And my last step is to add that 2. So we get y equals the square root of negative x plus 4, and I've added the 2 to get it to the other side. Do put it in the correct notation, especially on the test, because we do award a point to that. So you want to have it in that correct inverse notation once you've finished. All right, if you want to try another one, you can pause the video and try this one, but I'll go ahead and give my last explanation on that one. I switch my x and my y, and now I'm solving for this y, so I'm going to add the 7. I'm going to go ahead and square both sides. That frees my y plus 3 because those two cancel. And I'm left with x plus 7 squared. And now I want to subtract this 3 to get it to the other side. Now, when I declare it, it's inverse, so I write it in the proper notation. I need to put my domain restriction because I know that this is a full parabola and this is only a part of it. So I want to put my domain restriction, and so I'm going to say x is greater than or equal to, my vertex right here is at -7, -3. So I want it greater than or equal to -7. That's inverse functions.